Let's take a look at number 9 from section 6.1. The annual increase I in the deer population in a national park is given by the formula I equals 1.1x minus 0.0002 x squared, where x is the size of the population that year. Okay, the first thing we want to do is make a table of values for x between 0 and 6,000 inclusive. Use increments of 500 in x. Okay, so I think our calculator could help us out. So in y1, just enter the formula. If you go to a second window, that's table setup. We'll start the table at 0, but change in table or delta table is that increment that they told us, which is 500. Okay, this is what the x's will increase by. And then just go to your table. So second graph. Okay, so we're going to look close to 6,000, and we can see that at 5,500, the y value is 0. And also, maybe if we need to graph this shortly, kind of take a look at those y values just to see how high they actually go. Okay, in part B, how much will a population of 1,000 deer increase? 1,000 deer is the population that's given. That's an x value, and we want to know the associated I value. And so if you think about these points that are on the graph, okay, they are of the form x, comma, I. So you can either just substitute 1,000 for x into the given formula, or just go back to the table that you just created and scroll down. So when x is 1,000, I is 900. Okay, a population of 3,000 deer. Okay, so we scroll down a little bit more. When x is 3,000, I is 1,500. And then lastly, a population of 5,000. Okay, so we see 500. Okay, in part C, we're going to look at the graph of the annual increase versus the population. Okay, so since we've already entered the function in y1, we're just going to adjust the window to match kind of this information that we already know, and that is to look between x equals 0 and x equals 6,000. So our x min will be 0 and our x max is 6,000. Okay, we also looked at the table earlier, and we could tell that the maximum y value was somewhere between 1,500 and 2,000, and so we can make the y max 2,000. Okay, and then select graph. Okay, part D, it says, what do the x-intercepts tell us about the deer population? Okay, so first let's just look at where those x-intercepts are on the graph, and we can use the trace key just kind of to trace around. Okay, so we see it's around 5,500, but we also saw from the table that that is where an x-intercept is at 5,500. And then if we look to the left at 0, that's another one. Okay, so the x-intercepts are at 0 and 5,500. Okay, remember these are population sizes, and so when the population size is 0, the annual increase I is 0, but when the population size is 5,500, the same thing happens. The population won't grow at all. And then lastly, estimate the population size that results in the largest annual increase. So that's the largest I value. And what is that increase? Okay, so going back to the graph, we're looking at this high point of the function. So that's at the vertex of this quadratic. Okay, if we use the trace button again, we can get close. Okay, and so somewhere around 2700, something like that. Okay, but if we want to get a little bit closer, more accurate, then we can use the max feature of the calculator. So second trace, maximum, which is number 4, and then just scroll to the left of the vertex and hit enter, and then scroll to the right of the vertex, okay, and hit enter, and then guess. We really don't have to move the cursor at all, but just hit enter one more time, and it's going to tell us where that maximum is located, which is at really 2,750. Now, what is the increase? That's the y values. Okay, so about 1,512.